Hi folks, welcome back to Math with Captain Rod. Yeah, no mood music on this one here. So we're going to take a look at number 8, section 14.4a, where it says an air conditioner needs 16 minutes longer to cool a room 4 degrees than does a larger air conditioner. Together they can cool a room in 6 minutes. How long does it take each? So again, just like my previous couple videos here, what I want you to do with all these story problems is give me some sort of classification. Is this a distance rate problem, or is this a work job type of problem, or what I just called other? This one right here is a work problem, right? Because these air conditioners are trying to complete a task, so this is a work problem. So we're going to start by writing out the following formula here. Jobs completed equals rate times time, where a job completed here is going to be cooling a room 4 degrees. Right, next step, define variables here. Let's see, an air conditioner needs 16 minutes longer to cool a room than does a larger one. So maybe we do something like, let's let X equal the time it takes the larger air conditioner to cool the room. Now, I'm just picking one. You could also let X equal the time it takes the smaller one, right? It really won't matter. But the next step will be different depending on how you set it up. Because it says an air conditioner needs 16 minutes longer to cool the room than the big one. So my X is going to be the time for the larger one. So the time for the smaller one is going to be X plus 16, right? For smaller one. Had I defined X as the time for the smaller one, then the bigger one would be X minus 16. So it doesn't really matter, but you have to follow suit. What this looks like is going to depend on how you define this. All right, now, these are times, not rates. So I've got the big air conditioner and the smaller one. Actually, let me do this. Big, smaller, and over here we'll say together. So if the big air conditioner can cool a room in X time, then its rate is 1 over X. That would have units of room, like rooms cooled per minute or something. All right, so that's now the rate for the bigger air conditioner to cool the room. For the smaller air conditioner, if it takes this amount of time to cool it, then its rate would be 1 over X plus 6. Right? This would have units of rooms per minute. Together, right, their rate together, we add the two. So 1 over X plus 1 over X plus 6 is now the rate at which these will cool the room when working together. Right, now I'm going to try to write some sort of equation for this. Let's see. Together they can cool the room in 6 minutes. So I'm going to use this formula here to write an equation for that, and I need a little more room here, so let's do this. All right, so working together, jobs completed. They can cool one room, right, equals rate 1 over X plus 1 over X plus 6 times time, 6 minutes. So again, this would be rooms completed. This number has units of rooms cooled per minute times 6 minutes. And then we now have the following equation to work with, and the unknown is X. So now, let's see. Let's start working on getting that thing solved. Looks to me like we better multiply everything by X and X plus 6. That will get rid of the denominators. So when we take this guy times this guy, I'm going to put this over here. We're going to have X times X plus 6 equals. Now when we take, I'll do this here. When we take this times this, notice that the x's will cancel. And we're going to be left with just x plus 6. And when we take, whoops, and don't forget there's a 6 here that has to hit that as well, so put that there, times 6. And now when we take this times this, the x's will cancel and leave us with an x plus 6. But don't forget there's also that 6 there as well. So that other product is going to be plus 6x, I guess, right? We're taking this times this. The x plus 6's cancel. We're left with the 6 and the x. Yep, all right. I think we're good here. I think there's our equation, which probably will end up being quadratic based on the unit this thing's in. So we'll start looking for x here. So I think we're going to probably have to distribute this. X squared plus 6x equals, we're probably going to distribute over here, 6x plus 36 plus another 6x. Now, recognizing it's quadratic, I'm going to set it up for solving it using the quadratic formula. So this we're going to leave alone. We're going to want a 0 on the right. So let's see, we're going to subtract 6x. These are going to be gone. Then we're going to subtract, let's see, another 6x. So minus 6x, and then we're going to subtract 36 equals 0. Yeah, maybe it's, I don't know, think about factoring here for a minute. Let's see, products at 36. 6 and 6, 12 and 3, 9 and 4. I don't see anything. Nothing's jumping out at me there. So usually when I deal with these, what I do is I give it to about, like 1001, 1002. If I can't factor it by 1003, I just go to the quadratic formula. So x is going to equal opposite of b, plus or minus the square root of b squared. Now, when you do something like this, a lot of you, I've been noticing you miss these parentheses. This minus sign is also being squared. You actually need these parentheses here for it to be mathematically correct. I notice that people miss this. They do end up squaring it. Their next line tends to be right. But for it to technically be all good to go, you need parentheses here so that that minus sign is being squared. So b squared minus 4ac all over twice a. All right, I think I'll move this over to here now. So x is going to equal 6 plus or minus. I'm going to go ahead and get a value here. Now minus 6 squared is 36, and this is going to be plus. So I'm just going to do this in one shot. We're going to get 36 plus 4 times 36. Okay, under the radical I get a $1.80 or 180, and I'm going to go ahead and square root that right now. 13.4. And then over 2. Now, x is a time. 6 minus 13 is a negative number. X is some time here. We're going to want that to be positive. So I'm just going to take the positive root here, or the positive solution. I got 9.7 minutes. Now, let's see. My x was the time it takes the larger one. For the smaller one, it's x plus 16. So I'll just do x sub s here for smaller, and I'll just put an L for larger. And 25.7. Didn't need a calculator for that, but all right. And hopefully, hopefully that's right. So again, what I need you folks to do is when you read these word problems, make sure you actively classify them. What type of problem is it? Okay, in this case, it is a work problem, right? And I want you to write that down. In fact, when I write that quiz, I'm probably going to put a part on there that says, please classify this problem, right? Second, write down the formula that we're basing our equations on. Right? Next, make sure you define your variable very clearly. Next, show the setup, right, where we're getting this sum from. And again, you might want to focus a little bit on, why is the rate 1 over x? Well, I mean, imagine, imagine it takes, a guy painting a house is the example that seems to always pop into my mind. You imagine it takes a guy 3 days to paint a house. Then the rate would be 1/3 house per day. When you take your time to complete something and then you do 1 over that, that's always going to give you the rate it takes, right? And then use this to write some sort of equation. So hopefully this video helps with these story problems. Have a great day.